This meeting is being recorded.
For problem 19 in chapter 15, we're asked to draw the expected proton NMR spectrum for each of the following compounds. We're not going to draw it as a normal spectrum is represented, but we're going to use some shorthand notation to describe what type of peaks we would see. So let's take a look at compound A here. And we have these two protons here. Then we have two here, two here, and two more over here. So out of these four signals that we see, let's get started. So over here, we would see this methylene, the shift would begin at 1.2 for methylene protons, and then these are alpha to a carbonyl, so we add 1.0. So we would see a delta around 2.2 ppm for these two protons. The multiplicity, so our lowercase m here will give for multiplicity. We have two neighbors, so the multiplicity will be 3. And then our integration value, we would have 2 protons seen there. For this signal from these 2 protons here, we'll do the same thing. We'll do our delta, so we have 1.2 for methylene protons, and then they are beta to a carbonyl, so we're going to add just 0.2, so we expect our shift to be around 1.4 ppm. The multiplicity for this signal would be a quintet, and the reason for that is because we now have 4 plus 1 neighbors. We have 2 to the left, 2 to the right, so that will give us 5 peaks for our multiplicity. And then if we integrate, we would see again 2 protons, so integration of 2. All right, let's move to this next signal here. So we know our integration will be 2. Our delta is going to be, we start 1.2 for our methylene protons. Now this compound is beta to an oxygen of an ester, so we divide 3.0 by 5, so 1/5 of that signal, we would add about 0.6 to this, so we expect to see our shift at 1.8 ppm. The multiplicity of this signal, once again, this would be a quintet because we have 2 neighbors to the left, 2 to the right, so 4 plus 1 gives us a multiplicity of 5, a quintet. Our last signal over here, now we're going to have our shift start at 1.2. We're going to add 3 because this is alpha to an oxygen of an ester. So our shift should be approximately 4.2 ppm. Our multiplicity, there's only 2 neighbors now, so we would have a triplet. And then our intensity is once again for 2 protons. So the integration shown. So the integration is the same for all 4 signals, and the shift should be seen at those delta values calculated, and then the multiplicity, again, dealing with the n plus 1. We know based on the neighbors how many peaks we should see in each of our signals. Let's take a look at compound B here. So now we expect to have about 5 signals. This is a completely symmetric molecule, so we can start, we can count from one side here. So we would see this proton here produce a signal. These 6 protons here would produce a second signal. These 2 will produce a third, a fourth, and then a 5th signal. So let's write these below here. So for our first proton, if you recall from the table, table 15.1, this is or 15.2 rather, this is an aldehydic proton. So the proton of an aldehyde functional group would be around 10 ppm. The multiplicity here is going to be a singlet because there are no neighbors, and the integration would show just 1 proton there. Let's take a look at what we would see for the group of protons 2 here. So we have integration of 6 protons, 2 methyl groups. We'll do that first. Our delta, so we start at 0.9 for methyl protons, and these guys are going to be alpha to a carbonyl. So we would add, I'm sorry, these are beta rather to a carbonyl. So we add 0.2, not 1.0. So we get our shift approximately 1.1 ppm. Then we see our multiplicity. We have no neighbors here. So again, another singlet. All right, so let's move to group 3. So in group 3, we would have our shift. For our methylene protons, we start at 1.2. Then we add 0.5 and 0.2 because these are beta from that oxygen, and we are beta from the carbonyl. So we're going to add 0.2 and the other oxygen by itself, we add that 0.5 because we divide 2.5 by 5, and we end up with a shift here around 1.9. Then our multiplicity here, we look at our neighbors. So we have 2 neighbors, right? So these 2 neighbors giving rise to signal 4. So we would have a triplet for our multiplicity, and then our intensity, or rather our integration, shows 2 protons. All right, so let's look at signal 4 here. So the delta for the signal, we would have 1.2 for methylene. Then we're adding 2.5 because this is alpha to that oxygen next door. So now we have a shift of approximately 3.7 ppm for protons 4. And then we also have our multiplicity here. So we have 2 neighbors, so we're going to have a triplet. And our integration would show 2 protons, again for group 4. Now 5 I'll do over here. So we are again going to do the delta first. So we start with 1.2. We are alpha to that oxygen, so we add 2.5. And we are also beta to that carbonyl, or rather, we're alpha to that carbonyl, so we're going to add 1.0. So all together, we have a shift here of 4.7. And then we have our multiplicity. So how many neighbors do we have? We have no neighbors, so this would be a singlet. And then our integration shows that this would be 2 protons.